All right. Hey guys, it's Miss Lastly and Miss Marker, and we are here for day 3, Intro to Logarithms. Let's get to it. All right, so you guys did logs last year when you were doing your log and exponential unit. So a lot of this should be kind of review, but it's always a topic that students tend to forget the most. This unit does happen in Algebra 2 right around winter break. So sometimes you guys get so excited about winter break that you forget all about math, which I don't know who would do that, but it happens. So I like to go over it, everything kind of again, and we make it a little bit harder in this class like usual. So anyways, let's just get into it. So exponential functions, which we were talking about in our last 2 videos, they have an inverse, right? Like all graphs do. And the inverse of the exponential is the logarithm. So, oh no, right. Is the inverse of the exponential. All right, now before we get into looking at the actual equations, we're going to talk a little bit about the graph first. So tonight on your homework is actually going to really get into the idea of inverse as a graph kind of feature, and then like talking about the different like parts of the functions. But I want to kind of talk about a little bit just because it gives us kind of a visual to think of as we're kind of moving through exponentials and logarithms. So our exponential graph looks something like this, right? So here's our XY axis, right? Exponentials look like this. All right, we know that they have a key point right here at 0, 1. All right, well, since logs are the inverse graph, that means we can draw this imaginary line, y equals x. That is the ugliest y I might have ever drawn in my life. It's fine. All right, so we have this imaginary line y equals x, and the inverse is just the reflection over that line. So so let's just draw all of this exponential graph. So we also have this asymptote right here at y equals 0, right? So we have that starting point, and then we have the asymptote. So when we're dealing with logarithms, our starting point, instead of being 0, 1, is going to be 1, 0, right? It's just flipped. Okay, so logs, right? They have that point 1, 0. So that point right there. All right, and instead of having an asymptote at y equals 0, it kind of flips, right? So the opposite of y equals 0 is going to be x equals 0. So that you get an exponent, a vertical one, right? Just like that, x equals 0, right? And so your graph is going to look like this, right? So we have that mirror image on both sides of the line, y equals x. So you're going to do a little bit more practice with that on the homework tonight, where you're practicing going between exponential and then graphing the log equation. But that's the main idea, right? So when you have inverses of each other, the graph is going to be a mirror image over that line y equals x, and all of your points are just going to swap the x and the y values. So instead of, like I said, being 0, 1, logs are going to have the point 1, 0. Instead of having an asymptote at y equals 0, you're going to have an asymptote at x equals 0. So everything is really just kind of flipped. All right, now for the equation, this is the part that people tend to not like the most. All right, so if you have the exponential equation, a to the power of x equals b. So a to some exponent equals some number. And you want to transform that into a log. So this is exponential. All right, transforming it to log form looks like this. So it's log, that's the symbol for log. All right, a, your base number, is the base or the subscript of your log. All right, of, this is not multiplying, this is going inside of the log, b equals x. All right, so that's kind of where you have to kind of remember where everything goes. So the base number is, we still call it the base number of our log. So the base of our exponential is still the base of our log. All right, what it's equal to, so whatever your exponential is equal to, that's what goes inside of the log. and then the exponent itself is what the log is equal to. All right, so that's how you kind of go back and forth. All right, so you have your base number. It's still called a base in both the exponential formatting and the log formatting. All right, your exponent in the exponential is now what you're going to be equal to. And then what you were equal to in the exponential is now the number that goes inside of the log. All right, so I just want to kind of jot this down. This b is inside the log, not multiplied by the log. I see people say that it's multiplied all the time. It's not being multiplied. All right, when you hit the log button on your calculator, which we'll look at in another video, right? But you have a log button. It's LOG. I know you guys can't really see this. I don't know why I'm even wasting my time. But when you hit LOG, it opens up a parentheses. Your B value is what goes inside that parentheses. Okay, so it's in the log. It's not being multiplied to the log. Okay, so now let's go over some example problems. So first we're going to go from exponential form to logarithm form. So we're just going to practice going back and forth. Okay, so we have 4 to the third equals 64. All right, 4 is our base. So when we go to log format, we write LOG. 4 is our base number. It's going to be the base of our log. All right, so it's a subscript, so it's like written below the log. It's like the opposite of an exponent, right? It's on the bottom. All right, open up our parentheses. Okay, what it's equal to goes inside that parentheses. All right, so the 64 goes inside of our log, and then the exponent is what we are now equal to. All right, so that's our transforming from log to exponential, or sorry, from exponential to log form. All right, let's do the next one. Miss Marker, do you want to walk us through the next one, number 2?
Sure. So for this one, we are going to do essentially the same thing. So remember your base there, which is 10, is going to become the base of the log. So remember the subscript. So it's going to be log base 10. And then your 1000 there is going to be what's inside those parentheses. And then your exponent on that example will become what it's equal to.
Absolutely. Perfect. All right, so that is how you go from exponential form to log form. Now we're going to do the reverse. So the second set of examples is going from log form back to exponential form. All right, so let's check out the first one. So we have our subscript or our base of 5. So when we're writing this in exponential format, that is our base number. All right, what it's equal to, that is the exponent of our exponential. All right, and then what's inside the log is what our exponential is equal to. Now these ones, it's pretty easy because you can definitely double check to make sure it makes sense, right? Is 5 squared equal to 25? The answer is yes. Yes, it is. All right. So when you're going to exponential, like from log to exponential form, all right, it's kind of easy because you can kind of think of it like, okay, is this true? When you're looking at logs, you'll eventually be able to probably say, okay, is this true? Looking at log format, but maybe not. Maybe you still always have to convert to exponential, but we're so used to writing things with exponents that it just makes sense to us when we see it. And so we can definitely double check our answer. All right, Miss Marker, do number 4 for us. So what is going to be our base number?
Your base number is going to be 3. So remember that subscript right by the log. And then your exponent is going to be what the log is equal to. So it's going to be 4. And then 3 to the 4 is going to equal what's inside the log. So that will be 81. And you double check that looks right.
Awesome. So there you go. There you have converting from log form to exponential form. All right, last thing we're going to do is one of my favorite things to do, but I'm letting Miss Marker do it so she can explain it to you guys, because I've explained how to do inverses to you guys many times this year already. So I'll let her do the fun part of this problem. But Finding the inverse equation when you're given an exponential and transforming it to a log function. So a lot of algebra skills are going to be used here. Please take your time when you're doing the problems like this one, because they are pretty tedious and you have to make sure you're using your order of operations exactly correct. All right, Miss Margaret, what's our first step when we're finding the inverse?
So the first step when we find an inverse, any inverse, is to swap x and y. So you're going to end up with x equals, sorry guys, I'm not writing, so this might take a little bit of practice. X equals, and then parentheses, 3 to the y minus 3 over 2. And then that's all raised to 1/4. Okay, so the next thing you're going to do, just like Miss Leslie said, is we're going to pay attention to our order of operations. So we need to deal with that exponent there. So what we're going to do is we want to make that exponent of 1/4. We want that to be 1 to kind of like cancel or get rid of it. So you're going to put parentheses around that entire thing, and you're going to raise it to 4. So when you remember your exponent rules, that's going to get multiplied. So when you have a exponent raised to an exponent, that's going to get multiplied together. So that will equal 1. And then you're going to do the same thing to the other side. So you're going to get x to the 4th there. And you end up with x to the 4th equals just what's inside those parentheses. So 3y minus 3 over 2. And then from here, we want to solve for y. So we're going to multiply both sides by 2. And that will cancel out the 2 on the bottom there, and you'll end up with 2x on that side, or 2x to the 4th, sorry. And then we are going to run out of space. Yep. And then that's equal to 3y minus 3. And then we want to add 3 to both sides. And so then you end up with 2x to the 4th plus 3 equals 3y. Also, if you're confident, feel free to combine steps. Otherwise, write them all out. I like to write everything out, but okay. And then here's where we're going to apply that log rule. So remember, this is kind of reverse. So if this trips you up, we can rewrite this to 3y equals 2x to the 4th plus 3, if that helps you see it better. I know sometimes that is helpful to students. So from here, we're going to take our base, which is 3, and so we're going to get log base 3. And then remember, what goes inside our parentheses is what that exponent is equal to, so it's going to be 2x to the 4th plus 3, and that whole thing goes inside the parentheses. So it's log base 3 of that whole thing, and then equal to y, equal to that exponent up there, and that is your answer.
There we go. So there is going from finding your inverse of an exponential equation. All right. So remember, if you have an exponential function given to you and you need to find the inverse equation, your answer better have a log in it, right? If you're given a log equation and need to find the inverse, you better have an exponential equation as your inverse in some capacity, right? Same thing when you're dealing with like a quadratic function, right? So if you started with a quadratic, your inverse better have a square root in there, right? Because those are inverses of each other. So if you're starting with an exponential, your inverse better be a log equation because they're inverses of each other. All right, so excellent. And that is our video for today. That should help you guys get through your homework for tonight on intro to logarithms. Hopefully you guys enjoyed the video, and we will see you in the next one. Bye, guys.
Bye.